Welcome back to my channel. So today I have taken a topic on a little different type of topic, that is active signal conditioning. This type of active signal conditioning is used for industrial monitoring, like sensors which you monitor of the industries and all. So small project here based on operational amplifier in Arduino board. So I've taken this topic. I will explain what is it exactly. So industrial temperature monitoring with active signal conditioning. So this is the topic name or name of our project. All right. Okay. Now let's go to the description part first. So real world hardware project that demonstrate industrial signal conditioning. Now, what is industrial signal conditioning? That is the up down which happens in the industry. Whatever we different type of sensors we use in the industry. So different type of values we have to analyze, we have to make it good, or we have to convert it to some other values, we have to remove the noises. So that is called as signal conditioning. So that is all required by the industry. This project uses an industrial PT100 RTD. That is PT100 RTD. PT100 is a temperature sensor. That is PT actually is platinum coated. Okay, the platinum coated it will be there, and 100 is a number. And RTD is resistance temperature detector. Okay, so very common temperature, because from very low to very high up to 1000 and more than that also you can count on this. Used for industrial purposes like boilers and other things, boiler temperature and all. There they use it. Okay, anyhow. So or in my case, in here we have used only thermistor, but I will tell you why and how. Okay, commonly used in factories to measure temperature up to several hundred degrees Celsius. Okay, so because of PT100 only changes its resistance, because it's a resistance, by a tiny fraction per degree. Okay, per degree, tiny fraction, that is 0.01, it will change the voltage. And Arduino cannot read it directly. So you will build a signal conditioning circuit using LM358. That means before giving it to the Arduino, we are using a circuit that is LM358 to filter, amplify, and scale the tiny signal into a clean 0 to 5 volt range. That means the slowly when the temperature increases, the voltage also increases from the Arduino ADC, that is analog control. Okay. Now here we have used a special V-stone bridge. So what is V-stone bridge? We use a bridge configuration to set the PT100 against the 100 mega ohm, 100 resistor, not mega ohm, 100 ohms resistor. This balances the circuit to 0 and up to 5 volts. Okay. So first we have to understand what is Wheatstone bridge. Okay, so I will just go to the next slide and I will show you here. So you can see here a Wheatstone bridge. This is the resistor, the combination of 4 resistor as a bridge, right? Equal resistor can be equal resistor. That means 2 resistors in series connected to source. One end will be going to positive, or another end will be going to negative, and same thing will happen another parallel to it. This 2 series parallel to it, 2 more resistance will be there with the same positive and negative, and the center point has taken as 1 and 2 output. The like in our bridge circuit, that is a rectifier circuit, will take plus and minus from the bridge itself. Here also the same, 2 inputs, that is here from that is supply, and 2 outputs, that is A or B, or 2 outputs we can see. The project is split into 3 hardware stages, basically 3 hardware stages. The Wheatstone bridge we call it as, that is when the input signal is given, it is given through the Wheatstone bridge, so that the point voltage change will also show on your Arduino board, in the output of the Arduino board. That's the reason. Okay, convert the resistance changes PT100 into small differential voltage. Okay. The second is the LM358 amplifier and low pass filter. So we have used the LM35 amplifier, that is as a low pass filter. This is LM35 is operational amplifier. You can say, yeah, it's operational amplifier. Clean, what is that? Clean industrial high frequency noise amplifies the millivolt level signal from 0 to 5 volt scale. Third is the Arduino ADC, that is we are using a microcontroller. The microcontroller board is Arduino board. We are using analog DC to it and process the voltage and display the temperature. So these are the 3 stages we will be going through. Okay, right. So Wheatstone bridge, I just now told you what is the reason. The hardware components required is microcontroller. Okay, any microcontroller you can take. any microcontroller will do, that is Arduino Uno, Nano, or Mega. Sensor to wire PT100 RTD temperature sensor or thermistor. In my case, I've used a thermistor just to show because I'm not having PT100 RTD. So operational amplifier 358 dual amp, it is an IC. Then passive components, you have 100 ohm resistor, 0.1, 1K for bridge, for your Bridgestone bridge, we have used 10K kilo ohms of resistance and all. And through 100 kilo ohm, we have to give it to the feedback that is used as a feedback from pin number 1 to pin number 2, right, of the IC. That is LM358. Breadboard jumper wire and power supply 5 to 12 volt, anything you can use. I have given on the side the figures which we will be using. Okay. So this is Arduino software. Actually, this software is very, very simple. You can see here on right hand side, this is the program which you have to load on your Arduino board. Okay, so simple program that is to convert whatever the signal we are getting to convert it to voltage. Okay, so calibrate first. How you will go calibrate your industrial project zero calibration. That is, first you have to calibrate it properly. That is your sensor. Submerge your PT100 sensor in a glass of a crushed ice and water so that you get a start with a 0 degree. Okay, the voltage output on the Arduino serial monitor should be very low. That is 0. That means 0 degree start. It will give you 0 volts. Then gain calibration. Place the sensor in a boiling water of 100 degrees centigrade. Turn the 100 kilo mega ohm potentiometer on your board and check. You get the maximum 4.5 or 5 volt exactly. So let's go to our lab and exactly see how does it works. Here in our lab now, I will just show you on this breadboard. I have made a circuit that is your LM358 and Bridgestone circuit. Okay? And this is my Arduino board, and the output connection, that is pin number 1. From here, it is given to A0. A0. This is the point A0, and supply to run this circuit. I have taken it from 5 volt from here itself. Okay, so I will just give you a demo. Before that, I will just tell you what is Bridgestone circuit. These are the two resistors connected as a Bridgestone. Please remember that. And this resistor also have connected in the same fashion. So I have used, instead of T100, I have used a thermistor here. Okay? And a thermistor, then 100K feedback resistor. And also I've used one the LED light so that you can just see how the LED light comes on when the voltage is increasing. Okay, so right now, as you can see on left hand side on the screen, that is serial monitor, you can see the approximate voltage is 1.5. I'm not saying it to 0 because I didn't keep it to very low, like I didn't keep it to low, that is to 0. So I will just give you an idea how the voltage is working. What I will do is I will put iron near to this temperature sensor. You can see there this how this it is increasing gradually, right? You can see how gradually, and the light is also coming up to some this thing. So you can see here. Okay, so it is gradually increasing. If we go up to threshold, we can adjust it with the help of a Wheatstone bridge. We can adjust that is the voltage, how long it will go. So this is a very simple, like, so temperature related to voltage for the accuracy. And why we use this active signal conditioning in the industries, I've removed now. The gradually it will come down, please. You watch that also. So what is active signal conditioning is? It is a process of using power electronic component to manipulate raw sensor signal which are coming out from this. So we have to manipulate a sensor to ensure to transfer accurate, stable data to control, boost weak signal. Okay, this is the purpose of doing this circuit, and it is used for, I already told you, for boilers in the industry and other this thing. As you can see, gradually it is coming up, and I will just put it again the heat because I'm giving iron heat here. Heat I'm giving. See, you can see now gradually it is increasing. Okay, gradually it is increasing. As you can also see, the light also getting dim and how it will be going a little higher and lower. You can see this. That is the PWM paths, how it is working according to them. So I will be share. I have already shared. This is the codes for this. Very simple. Okay. So A0 is connected 1 pin, 5 volt. As I told you, we sensor value we start with 0. Of course, we are not started with 0. Of course here, but we will start with 0, and analog pin. The baud rate is 9600. As we have kept it here, then only we are getting this voltage. Okay. And serial pin condition of voltage, and we are converting temperature to voltage gradually with the help of a Wheatstone bridge. That is called as active signal condition. So this is a new topic which is important. So that's why I thought I will just make a small video on this and try to teach you it. Thanks for watching. See you next time.